Okay, let's talk about the best time to buy and sell stock for. You're given an array where at each index I, array I is basically the price of a given stock on that day, and you are allowed to complete k transactions. And the definition of a transaction is one buy and one sell, and you can only do one operation a day, so you can't buy and sell on the same day. You have to buy one day and sell another day, and you're allowed to do that k times, and you want to find the maximum profit given this array nk. So if you look at the second example, here are the prices and here's k. What's optimal here is you want to buy on day 2 when the price is 2, and you want to sell when the price is 6, so that gives you a profit of 4, and then you want to buy again on when the price is 0, and you want to sell when the price is 3, and in total that gives you the profit of 7, which you will then output. So the way to do this problem is dynamic programming, and I'm just going to talk about how to do that. The way you do it is you define dp of ij to be the maximum profit at time I having done j transactions. And usually the way things work is that if you define what dp of ij is really well, you will be able to easily do you'll be able to easily come up with a recurrence. So let's try to find a recurrence for dp of ij, and by that I mean express dp of ij in terms of other dp values, and that'll give us a nice way to fill out this grid. So dp of ij, we're going to be taking the max of some adjacent elements in the grid, and so there's really multiple options we could do when filling out this grid. The first thing to note is that when we're at time I having done j transactions, one way for us to have gotten there is to just simply have held. So if we did not do anything at time I minus I because it wasn't optimal, then we would just hold here. And this is kind of like the first thing that we're considering in our recurrence. So either we can hold or we can sell. And selling is pretty interesting, right? So if we want to sell, we want to sell with some index before I. So let's call that L. So if we want to sell, the amount of profit that we get is array I minus array L. But how do we know what L is? What's the best option for L? Clearly, we basically, oh, sorry. We basically might have to iterate through all the values between 0 and I minus 1 to get the optimal value here. And so what we do here is we add on another max here, and then we do this max over L, and L goes from 0 to I minus 1. But so here we sell this current stock, but we also have to keep into account whatever dp value was before we have gotten to L. So we need to do dp of L minus 1 and then j minus 1, because the reason why we do j minus 1 is because we are like this sell operation is a transaction, so we need to have done one less transaction in order for this transition to occur. And this is basically our recurrence. And so when we're doing DP, we ideally want to kind of have a constant time way of doing this. We want a constant time way of calculating each DP of ij, but here, as it stands, this bottom term is like it would take linear time. So let's try to analyze this and see if we can get this down to constant time. So I'm just gonna call this star. So what you'll note here is that if you look at this array of I term, right, this array of I is not dependent on L at all. So we can just take it out of the max completely. Let me fix my handwriting. And then what we can do is we can rearrange. So I'm just going to take array I out and then rearrange so that this DP value comes first, and then we subtract array L. DP of L minus 1, J minus 1, minus array L. Yeah, so this second value, this thing covered in blue is equal to this, right? But as it stands, there is a quick way to calculate this, because if we go through I from 0 to n, we can just keep track of the maximum value we've seen so far. So if we just call this the so what I'm saying is that, so let's say, how do I phrase this? There is an easy way to calculate this in constant time if we are looping from from 0 to n minus 1. And the way you do that is that, so let's call this max diff, right? So when I is 0, max diff is just minus array of 0. This is because like these guys, like this wouldn't matter, so this would become 0 and you're just left with minus array 0. Great. So when I is not equal to 0, we can just have max diff is max diff, the max of max diff, and dp of I, j minus 1 minus array of I, or I minus 1 rather. And if you notice, you can calculate this. Can be calculated in linear time. Yeah, and that is pretty much it. It's it's a pretty interesting DP problem. Definitely not the easiest to come up with the solution, but I think with if you had gotten this definition down, it really becomes quite straightforward to come up with the recurrence. So that's the intuition behind, all right, that's how you solve the problem. Let's try to code it up and convince ourselves that it works. Max profit, I'm gonna call this array. Yeah, so let's just code it up real quick. First I'm gonna get the size of the array. If the array is empty, then I just return 0. Great. And then let's start up the DP array. Vector int, DP. We're going to have n rows because I goes from 0 to n. And then we want to go from j to, we want to do j from 0 to k inclusive, so we're going to need k plus 1 elements here, and then we start everything off at 0. And then if you note, if either I or j are 0, then dp of ij is going to be 0. That might actually be worth writing down. I'll write it down here. I is 0 or j is 0 kind of implies dp of I, j is 0. Why? Because let's say I is 0. You must have, because you can only buy and sell on different days. like you didn't have the opportunity to really make any transactions and make money yet, so you're going to be at 0. And the same thing if j is 0. Uh, remember, j is the amount of transactions that we've had, so if j is 0, you haven't done anything as well. So that actually makes implementation quite easy, because we can just start I from 1 and go to n like this. And then we can start j at 1 as well. J is less than or equal to k. Yeah, and yeah, that really makes things quite easy. And now I'm just going to write down what we had before. Remember, we had this max diff. Yeah, so I like iterating over j first, just because of the way we define this max diff thing. But I'm sure there's a way of doing this while iterating over I first. Great. Max diff equals minus array of 0. And then for each I, what do I do? So I do dp of ij is equal to max of dp of I minus 1j and the array of I minus max diff, I think. And then max diff is max of max diff and dp of I minus 1, j minus 1 minus array of I. And here, I did mention this, but because we want to find a max profit where we can make at most k transactions, we could just update the result each time if necessary. And then finally, we can just return a result. Let me make sure that this kind of fits into the formula that we wrote. Oh wow, that was beautiful. dp of ij, I minus 1j, yes. Array I, oh, this should be a plus. Or no. Array I plus max diff. Yeah, this should be a plus. Yeah, and this is about it. Let's run it. Hopefully there's no bugs. When you're copy pasting for loops, you always have to be careful, because there's just so many running parts. And yeah, it was accepted. So yeah, that's the main idea of the solution. Thanks for watching.